Cool, okay. So welcome everyone. It's cool to see so many people actually found the room. Unless you actually found the room this morning and never found your way out again, because it was sort of a back room, I must admit. So you're in the room with the talk exposing the not so secret practices of the cult of DDD. If that was not what you intended to see, I won't be offended if you leave. My name is Klug. I work as a software developer, architect, consultant, and public speaker at a company called Active Solution in Stockholm, where we do custom development on the Microsoft platform. And I've been doing dev on .NET since basically .NET Framework 1.1 or 1 even, a little bit. And I got this talk because I started reading this book again. This time I actually got all the way through it. Last time I read it, which was a few years ago, it put me to sleep so many times that I just gave up. It is dry. So how many in the room have actually read this book all the way through? No, yeah. And I started reading that book and I really enjoyed it. And I think it fit me better today than it did previously. So I actually went through it and realized there is a lot of really good stuff in here and I want to do a talk about it. But I don't want to go all DDD. I want to look at the things that are pragmatically possible for a lot of us. I actually read that book as well. So if you are getting into DDD and you want to read books about DDD, I would recommend these two books. They are, at least the blue one is really dry and will put you to sleep unless you happen to be in the right mood, in which case it will also put you to sleep, but a little bit later. The red one is a bit more practical and it's newer, so it's kind of more up to date when it looks at the code examples and things like that. The Eric Evans domain-driven design is fairly old, and the samples are written in Java, most of them, which is not that hard to read, but it feels old, I don't know why. But before I go any further, I need to put this disclaimer up here. I am not going to bash DDD. Even though the talk is named something like Cult of DDD, I'm not going to go and say that DDD sucks in any way. I think DDD is actually really good. I love a lot about DDD, so I'm not going to bash it in any way. But I'm also not going to tell you that everyone should use DDD, because it doesn't fit everyone. And that's not in the way that it doesn't just not fit you because you code in a different way or blah, you used the wrong language or something like that. It's actually a more practical thing. So for me, I cannot go full DDD. The reason for that is that I'm a consultant. And I love being a consultant because I get to go to companies for both short-term and long-term projects, and I get to see a lot of different areas and different companies and a lot of different cultures and problems and things like that. But it also means that I cannot go DDD, because the idea of DDD is about building knowledge about the domain and the ubiquitous language and all of that, and no client is going to pay me to spend 6 months to a year at the company to figure out the business processes and the domain that I'm working in, just to go and say, hey, thanks for the information, and then leave. I'm too expensive for that, unfortunately. So for consultants, it's a bit harder, so it won't fit everyone, but if you're in a product company, it might be a little bit easier to go full-blown DDD. But yeah, because of that, I wanted this talk to be things that we can do even if you don't go full tilt DDD. But I guess we need to have a little quick recap of what is DDD. Well, domain-driven design came out of, as I mentioned, Eric Evans' book, Tackling Complexity at the Heart of Software. I also had to put 2 pictures here because the Portuguese version looks a lot more messy. I don't know why. It's just funny that they have different covers on the book. That's the only one that is different. It's the Portuguese one. Everything else is these nice lines and everything like that, but apparently coding in Portuguese is messy. And the book is pretty much from cover to cover about ubiquitous language. Now, I know that I am in a country where English is the native language. How many of you are not from the UK? Anybody? Okay. Most of you, okay. How many of you do not have English as your first language? Cool. How many of you know what ubiquitous means? How many of you know what ubiquitous meant before you read about domain-driven design? Okay, a couple. Ubiquitous is a weird word. and I'm from Sweden, which is probably apparent from my English, but I went online and I basically punched it into Google to see what's the definition of ubiquitous. I kind of understood it, but I want to have the real definition, and it basically says found everywhere. Okay, so ubiquitous language is a language that is found everywhere, but not true, because it's actually a language that is found everywhere in the domain that you're working in, according to Eric Evans. And it's actually not true either, because it's a language that's available everywhere in a part of the domain you're working on. It's not very ubiquitous, it is, right? But yeah, that's the general gist, the ubiquitous language. So it is all about the language that they are using in the domain and translating that language into your code so that your code reads in a way that the domain experts can understand what you're doing, or at least parts of the domain. So for example, you go into a meeting, you talk to one of the domain experts, somebody working at the company, and they say, based on the client's discount, we can calculate the total cost of the purchase. Fairly simple thing, right? We can all understand that. We get a little vision in our head of the C# you need to write or the code you need to write to do that. And then we go out and developers and we turn it into, once we have the user's discount setting, we can update the total price on the order. Same thing, right? It is the same thing. It says the same thing. It's just phrased slightly differently. And then we go and implement that in code, and our code ends up looking something like this. We get the user ID, we get the current order, we get the discount setting, and we update the current order total price based on the discount setting, and then we pull out the total cost. How many of you would be okay with this piece of code based on the input that we got from the domain expert? Yeah, pretty much every one of us. It's like, why not? It works. It compiles and it does what it's supposed to do. It does, but this is what they said. They said, you get the current purchase, not the current order, because purchase and order are probably interchangeable, but they are different words. And in the domain, we're using the word purchase, not order. And also, we said calculate the cost based on the client's discount. Now we have calculate total cost instead of update total price. And we have a client.discount because it was based on the client's discount. It wasn't based on the discount setting for the client. So once we take that tiny little change, we end up with code like this, and then all of a sudden we could pretty much show this to a domain expert and say, does this look right? Was this what you said in that meeting that we needed to do? And they go, yeah, sure, that looks good. Highly, highly hypothetical and theoretical and probably not going to happen. But that's kind of the idea behind the ubiquitous language. But when you get beyond the ubiquitous language, or you dive into the books, you actually realize that there are things in the books that is beyond, or parts of the books, but is not ubiquitous language. More technical things that I thought was interesting to turn into a talk, because I realized that I use a lot of these technical things in my code on a daily basis, and it makes things better, in my opinion. And then I thought, hey, maybe other people can do the same. So in the books, they're actually called tactical patterns. So a tactical pattern is a code pattern that you can use to make your code more readable, more based on the ubiquitous language. Things like value objects is talked a lot about in there. Anti-corruption layers, which sounds so much cooler than it really is. Domain messages is another thing that Eric Evans talks a lot about. But there are also what they call strategic patterns in there, which is more high level, like architectural patterns. How can we organize things? How can we get the architecture to work? Things like splitting your domain into several subdomains or core supporting in generic domains. Bounded contexts is another concept they have in there. And then really generic things that is actually talked about in the books as well, like consistency. It might just be my background as a developer, but from what I see, we as developers tend to be very happy with the happy case. It is so unlikely that our network connection is dropped between point X and point Y because they're just 2 calls apart, so we just ignore it, and then consistency can be bad. There's a lot of talk about how to get better consistency and how to think about consistency in your systems. They talk about layered and hexagonal architecture, for example, in there, and more. But before we dive into these different areas, which are a bit scattered, there's not going to be like a nice red thread running through the whole thing. It's just going to be loosely coupled things. But it is important to realize that for domain-driven design, the technical stuff that we'll be looking at is there to support us to get a ubiquitous language and a domain model that's beautiful. It is not the technical things that are really important, just important to get out there. They're still the most fun to talk about. Eric quotes it as, the heart of software is its ability to solve domain-related problems for its users. All other features, vital though they may be, support this basic purpose. And I think that's one thing that developers tend to miss out on. And I'm going to say something that might rub a lot of people the wrong way. And I don't really care, because I think I'm the biggest guy in the room. Your code has no value. Anybody disagree? Actually, most people seem to be agreeing, or you just don't want to jump up and punch me. No, the thing is, I firmly believe that our code, the code that we write on a daily basis, and I write a lot of code, has no actual value. The value of our code comes out of what the code does, not the actual code as such. And this kind of what I'm saying is like, code, the software is there to solve domain-related problems. But that's what it's there for. Your code is not the important thing, and the technical things we put in there is just to support that thing, to support the ability to solve domain-related problems. Now, having that said, it is just object-oriented programming. That was one of my sort of awakenings with the books. I started reading the books, and then I decided to do the talk, and I started looking at the things I wanted to put in the talk, and I realized, actually, very little of this is in any way connected to domain-driven design. It is just the fact that it's actually object-oriented programming. And I know that we all think that we're doing object-oriented programming because we're using C#, which is object-oriented, and we're doing inherit in some places, and then we're doing object-oriented programming. Not really. But you look at it and you can do really beautiful things with object-oriented programming if you just think about actual objects and how to do them, and then all of a sudden you start doing weird things like doing internal classes and protected internal and all of these different things that for most of my programming career was completely useless. Why would I ever use protected internal? It's a weird combination. Why would I need that? And then you start doing actual things with it and you realize, oh, you can hide things. You can make it available, but still hiding it for other people so they don't see it. And that's kind of where this put me in a position where I care about how everything looks and how everything works. Before I go into my samples, once again, another disclaimer, my examples suck. I'm okay with that. I don't really care. If you have any problems with that, I will gladly see you try to do samples that are small enough to fit on one slide in PowerPoint. Also, by the way, try coding in PowerPoint. It's really hard. And second of all, has enough information to show off the concept that you want to do, which is really hard, which is why my examples are contrived. They're stupid in every single way. And I had to put this disclaimer in there because I have a demo or a sample piece of code that when I ran it in my company, that was the only feedback I got. That's wrong. Because in Sweden you have a personal number, which is basically every Swedish citizen gets a personal number, which is generally based on your birth date and 4 control digits, or 4 digits afterwards with 1 control digit at the end, blah, blah, blah. I wrote a simple piece of code to explain that, and then they tore me apart because my company produces a NuGet package that actually handles personal numbers, and it's way complex. So my samples are contrived, they're stupid, they're simple, but they are there to show you the concept, right? So here's a bit of code. This is actually going to be really hard for you in the back to read. I'm sorry for that. Can you see it? Okay, I got 1 thumbs up at least. It's a young guy that has good eyes still. How many of you have seen code that looks something like this? You go in and you get the user from a repo, you check the inputs, you check the first name input, the last name input, you check the age, and then finally at the end you set the first name, last name, and the age, and then you save the user using the repo. Anybody seen code like this before? Anybody write code like this? Yeah, there's nothing wrong. I wrote tons of code like this. There's nothing wrong with it, it's just not good. Sorry to say. Because it muddles responsibilities and it muddles things in there. It's like this method now has validation logic that might need to be reused somewhere else, right? And it's complicated. So Solution to that for a lot of people is removing all of the validation stuff and put that into a validator class so you can reuse the validation, right? That's really brilliant. I like that. It's a step in the right direction. But once again, it forces the user of your user class, like the developer using your user class, needs to remember to call validate first name, validate last name, validate age before they set the thing. Which is, it's nicer code, and it is reusable because this part here in the middle where it does the validate stuff, that's reusable, fine. One step in the right direction, and you can do fluent validation and all of that funky stuff. But we've got property setters, right? Property setters in C# has been there from day one. It's part of being an object-oriented language. If we move the validation into the setter of our properties, it means that we don't have to have a validation class that does the validation for us because it's built in here. And it also means that the user of your class doesn't need to remember to call the validation logic. It is built into the thing that they're using, and all of a sudden your code looks like that. Nobody's like, oh, okay, who really cares? That is much better, right? In my opinion. It looks nice. I really like the way that that looks. It's a step in the right direction, no doubt about it. And Eric talks about kind of this thing by saying, like, the beauty of objects is their ability to encapsulate all that, which is the complicated stuff, so the client code is simple and can be interpreted in terms of higher level concepts. So basically, when you pull out the code and you start using the user object in this case, because of object-oriented programming and using setters, we don't need to know how to do the validation because it comes with the thing that we're using. We should make the API for any class that we're using so simple that you cannot fail using it. That is going to be impossible because developers are really good at failing using things, and they are very creative. But it at least pushes them in the right direction, right? Now, DDD would probably take this one step further. And I'm still, honestly, I'm still getting to this point to actually do this, but DDD people would be able, oh, actually, step one I will do. They will probably look at this and go, that's something we do together. We update the first name, last name, and the age. That's personal details. So we'll introduce a method called update personal details. Once again, we are now making it even simpler for the end user to know how to use the user class, because if I want to set the username or the name or the first name, last name, or age, I call this method. And then I can set the setters for my properties to private sets, so it's not even possible to modify them without going through this, which is basically forcing the developer to do the right thing from the start. This I will do, and I have done in a lot of cases, but DDD introduces the idea of value objects. Now, value objects is probably the best thing I think you can take out of this session and bring with you into your code, because it is such a cool thing. What you do is you basically say that first name, last name, and age is a value. Chris, what? It's not a value, it's 3 values. No, it's not. It is personal details. Personal details, if I consider them being a thing that is updated together and lives together and always changed together, it can be an object. It can be a value. So if we create something like this, in this case I create a record, so basically I have a record with a constructor that takes the first name, last name, and age. It has the validation for first name, last name, and age in here. And then, there wasn't much more in here, but then we have our properties out here, first name, last name, and age, and we have init instead of sets on them. It means that it's immutable, and it means that everything is encapsulated with all of the validation logic in here. Which means that we can remove that update method. We can remove the first name, last name, and age property of our object. We can turn it into a single personal details property, and we can make it public get set. Because being that you cannot create a personal details object that is not valid, we don't need to have any validation here. We can trust the end user to update that object because, hey, it cannot be created in an invalid state. It cannot have a null value in there. It cannot have invalid things in there. So we can simply go with a simple property. Our user class becomes even simpler, and updating it is just a matter of doing that or setting it. Or you could potentially use since we're using records in this case, we could use the with if you want to do it like that, so if you want to update it instead of setting it. But we can basically trust the end user not to be able to screw up your code. It's like simplified, but still nice. Value objects have a few characteristics. It has 3 that are important. A, it has value equality. So basically, the way that you compare to value objects is that you compare every single subproperty of it. So the personal details, it looks at the first name, last name, and age, and if all those 3 properties are the same on 2 objects, they are equal. They do not do object reference equals. Immutability, you can never modify a value object. You create a value object, and then if you need a new one, you create a new one based on that, so you have immutability. And this fits very well into C# records, because records do have value equality by default, and they are immutable by default, and they have that with keyword for you to be able to modify them and get a new instance back, which is pretty nice. And they're self-validating. So you need to have validation in there. And if you look at my personal details here, because it's a record, it's immutable and it has value equality. And because I have init setters down there, it is immutable. And because I have validation logic in the constructor, it means that it is self-validating and can never be created in an inconsistent state. So I really love these. They are awesome. But there's more to it than just being able to take 3 properties and make them into one thing and remove a bunch of lines of code in the user object. If you take the record class, or color, sorry, the color, record color, the value object color, which is one of the value objects that Eric Evan talks about in his book, color, and we have that in C# as well. So the color class is a value object. It is a value equality. It is immutable. But it's kind of cool because I have this record color. It has a constructor that has validation for red, green, blue because I'm doing RGB. But then I can do more because I can do things like have a static from hex method. So I can go color from hex, and it takes a string and then a bunch of string manipulation to figure out the actual values in there to get them out there. I can do things like mix with. So basically, if I have this color over here and then I have this color over here, if I mix these 2 in this ratio, I get another color back, so I can know I can do mixing things. The only thing you need to do then is be smarter than me and figure out how to do the mixing in there, but smart people can figure that out. But all of these are, once again, immutable methods. So basically, they will create a new instance of the thing that you pass in. So it doesn't mess with mutability, but it gives you help, right? So here is that class that I wasn't allowed to show at my office. This is the way that it works with Swedish personal numbers. I renamed the class, so it's now called simplified personal numbers, so that I don't offend people at my office. So as I said, a Swedish personal number has a date, which is the first part of it, and then it has 4 digits at the end. It is a bit more complicated. It has a dash between the 2 things, and if it's a dash, you're less than 100 years old, and if it's a plus, you're over 100 years old. Really stupid system, because it means that you're identifying number in Sweden. When you turn 100, it changes. And most systems don't take that into account. So in Sweden, when people turn 105, they get a mail home saying that you are going to go to school and that you're welcome to come to an introductory day at the school. This happens over and over and over again because dash should be a plus. Anyhow, so I've got a constructor here. I made it protected because I don't want you to be able to new up one of these. And it takes a birth date and the 4 control the digits at the end. They're not all control digits, but anyway. And I basically can validate those in this constructor. I didn't put in the validate methods, but basically you can see they validate the different parts in here, so it's self-validating. And then I create static helper methods, so personal number dot from, and I pass in a string, because every personal number in Sweden is supposed to be a string with 10 digits with a dash or a plus. Or it can be a 12-digit number, which is not an official blah, 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 but from a string, okay? And then we can do from, we could do another version down here, which is, I know the birth date, and then the control digits and all of that. But because of the way that personal numbers are structured in Sweden, I can use my personal number to figure out your birth date. I can figure out your legally assigned gender at birth, because one of the numbers up here in the control digits, if that is an odd number, you're a girl. If it's an even number, you're a boy. So I can figure that out. And then I can give some extra help down here with formatting, so it always outputs it in the right format, in which case 12-digit format is not actually a real format, but a lot of people use it anyway. So it's more than just encapsulating. It's actually helping me with working with that type of value instead of just passing around the string at every single point in time. So I like them. Those helpers are nice down there as well. For the sake of being open here, no, the birth date is not actually your birth date. It can be a made-up date as well, because if you come to Sweden and you don't have any papers of when you were born because you're a refugee, for example, then you get 1 out of 2 dates, I think, a year, and then everybody in those dates, it gets too many, so they can't do the control digits, and then you get another date, and it's not your birth date. Let's just ignore that because you're not from Sweden, so you don't have to know that. But now, being that it's being recorded and people at my office might see this, I just want to make it clear that I understand how it works. But they can be even simpler. So instead of taking it and saying, hey, they're good because they can be more complicated and give you more functionality, I can also say they can be even better because they can be even simpler. Pop quiz. What's wrong with this? What's wrong with this code? Nobody? Yeah, so the actual problem is, the answer was here was, what does the 3 and 5 mean? Kind of correct. The actual problem here is, it's supposed to be 5-3, right? Because the first part is, yeah. How many of you have written code like this and managed to push in the wrong value at the wrong place? How many of you have gone in and updated a method and added another string parameter, but you put it in the middle and then your old code still compiles, but they come in the wrong way? Happens all the time. You know how simple it is to fix? You add that. Literally that. That is all the code you need. Public record user ID and public record group ID, and then it takes a value, which is 2 ints in this case, because I'm using ints, not strings, and then your code becomes that, which is brilliant. And it reads simple. Now, one thing here is that I had somebody suggest, might have been me in a not too bright state, saying, oh, well, you could ignore this, you could skip this if you just did an implicit cast operator, so ints could be turned into these values. If you do that, you're actually back to square one again, and it's just dumb, so don't. But this is kind of cool, and as I said, it reads nicely, because it basically goes with, you create an instance of my item by passing in a user ID and group ID, which is literally what it says. And that brings me to what I like about DDD as well. It's like, if you can write code that reads like language, it makes it easier to reason about because everybody knows language. Now, the reason I put language in there instead of English is because some people do like to code in their native language, which is fine. People code with Swedish variable names, which is fine because we've got these weird characters that only exist on our keyboards. Now, the problem with that is that it still doesn't become writing it in Swedish because all the keywords and everything is in English. So, but if we stick English in there, if you can code so that when you use your code, it reads like an English sentence, it is much easier to work with and much easier to understand what's happening. So an example of that is this. We get a user repository, and then we get a user we get users in the city Whoville. Now, probably should be double L in Whoville, but anyway, I hate this piece of code for several reasons. First of all, I hate that. I don't think, A, that we need to put repository in the name of the interface, because if it is a repository, you will figure that out because it will have methods that correspond to a repository. The fact that you're using a pattern called the repository pattern has nothing to do with your code. Can we agree on that? At least some of you go, yeah. Okay. Second part is that this pattern is what, 25 years old, 30 years old? And if I ask 10 developers the definition of a repository, I am going to get at least 8 different answers. because 25 or 30 years later, we still haven't figured out what a repository pattern actually means and what the definition is. So by putting that into your name, you're going to end up arguing with your colleagues about what it actually means and whether or not your repository should have a save method or not on it. Trust me, I know, because I've been there. And the only way to fix it is to have a bigger knife than the guy next to you. The other thing is, by removing that, it becomes iUsers, which I really like. And then I tend to actually name my methods on my repositories differently. So I name it living in instead of get by city. Because renaming it to living in means that I can say users in Whoville equals, okay, I can't get away from await, but then users living in Whoville. It reads like English, which then means that it looks nice. I kind of like it. It's like your code becomes like reading a book, kind of. Not really, but you kind of try to get it there at least. And then my iUsers repository or iUsers repository interface becomes with things like with ID, with premium subscription, with subscription of type, living in city, with ages between, which just reads nicer when you end up using it. Yes, it looks weird in the actual interface, but nobody is going to look at the actual interface. Everybody is going to look at when you use the interface and you press dot, what's going to come out in your IntelliSense, because we all depend on that thing folding out. And if that comes out and says with premium subscription, it's pretty obvious that you are going to get users with premium subscriptions. Ta-da! That's what I want. And then they spend a copious amount of time in the book talking about value objects versus entities, or actually they spend a lot of time mostly talking about entities. And the difference between a value object and what they call an entity is that an entity has an identity. So object that doesn't need to change over time doesn't need any identity. Identity is only there for objects that change, and because value objects are compared by value, not by ID or by reference, it means that value objects don't need an ID and they don't change over time. They're just a value and you throw it away when you're done with it. An entity has an ID because it is a thing that changes over time, and we need to track those changes to be able to go in and see what has happened or go in and modify the thing that we're working with. And identities are really important, like ridiculously important. But we as developers have to take a step back and stop putting database integers as the ID for every class we create. In some cases, it makes sense because it's useful, but in a lot of cases, it's dumb. So this, for example. If you're, once again, born in Sweden, sorry about the example, but it was the easiest thing I can come up with. So if I have a Swedish person, and I have a database ID, and I have a personal number, what is the most likely thing that people will use to search for this user in a UI, for example? The ID or the personal number? Probably the personal number. The ID is a stupid implementation detail. We have the ID in the database because we need a way to reference things in the database and have foreign keys, and a string, like a 13-digit string is not a good key in a database. That's not going to be very useful, especially since the personal ID goes from dash to plus when you're over 100 years old. So why not just use the personal number and hide the ID if you need it? Just put that as a private field instead, and then nobody can use it. No developer can go and say, oh, I'm going to use the ID. No, because the actual natural identifier for a Swedish person is the personal number. The actual natural identifier for a car is the vehicle identification number. There are lots of these cases where there's a natural identifier that is much better than the database ID. I'm 100% that I have an integer ID or a long ID in a database at some Swedish government system somewhere, but nobody knows that. It's not like I'm going to go, I'm person 8,664 in the database. No, I have a personal number, that's what we use. And since I assume that most of you are .NET developers, considering what conference we are at, and that means I assume that a lot of people use Entity Framework for doing their database access. Entity Framework has no problem whatsoever to reference a private field. The only thing you do is instead of going property and then lambda expression to find the ID, you put in property of t and you give it a string. If the string is a property, or references a property, it will set the property. If it references a private field, it will set the private field. If it doesn't, there's nothing in the class that has the variable name or element name underscore ID, it will become a shadow property that is managed by Identity Framework. And Entity Framework will do that without a problem. So we can do that with Entity Framework, which then means that no developer can go and say, oh, I'm going to use the ID, because the ID should never be used. And as I said, if you go and do this, and you just go property of t with ID, and you have this class here where there is no ID, Entity Framework will create a shadow property, and it will keep track of that ID inside the DB context without you having to have it on the actual object, which means that it is gone, it's never visible, but it's still there for your joins. And on the topic of Entity Framework, if you are using value objects, that can be used by using complex properties in Entity Framework. So you can go and say, hey, I have this thing called personal information. It is stored in the same table as my user data, but I want to take those columns and turn them into an object in itself without having a join or anything like that. Complex properties will do that for you. And if you have a really simple value object, like the user ID or the group ID, you just do a hash conversion, and then you can go and actually query in Entity Framework and say, find all users with user ID X, and it will figure out how to take your user ID and turn it into a value that can query in the database. So I want you to sort of start your development, or I do it at least, by designing objects the way that I want them to work. I will write my class in the way that I find an interface for my class that makes sense, that logically tells me how to use that thing, and then, if necessary, I adapt that to whatever Entity Framework needs. So sometimes I will have to do some stuff for Entity Framework, like foreign keys and things, but then I do that hidden as much as possible, basically putting it in private fields or hiding it in some way so that the user of my object gets a nice, simple API that makes sense to figure out how to use the API. Okay, so let's zoom out a little bit and look at a slightly bigger picture. How many of you have seen this diagram before? So there are 4 hands coming up and about 25 people lying, because you have all seen this diagram. You cannot be a developer without having seen this. I think the first time you open a programming book, they basically shove that in your face. This is diagram for the start of any architecture, basically, when you start coding. And it basically says that presentation is allowed to talk to business layer is allowed to talk to persistence is allowed to talk to infrastructure. And in the case of DDD, well, actually, oh yeah, one thing. Most people don't know that this is called a layered architecture, that you are not allowed to jump from this layer to that layer just because it's underneath. In a layered architecture, you're only allowed to talk to one layer beneath. So that is a no-go in a layered architecture. However, we're developers, so we basically said that we need to be able to go all the way down, so we're going to do this anyway. We're just going to rename it to a, what's it called? Sort of like simplified layered architecture or something like that, which is basically just, we will do this anyway, so we'll take the original pattern, just say that we don't care about that thing, and then use it anyway. And this is fine. There's nothing wrong with this in any way, and DDD talks a lot about layered architecture like that. Sorry, it's called relaxed layered architecture. But they name it slightly different in the name layers, so it's presentation, application, domain, and infrastructure. Those are the layers they've got. Now this is kind of neat. This works, not a problem. There is one tiny problem though. Messaging, because we are building a lot of distributed systems nowadays, which means that there are messages coming in from other things, or there can be other ways to insert information into your code or into your application. Now the problem with messaging is that it comes in at an infrastructure layer. So there's infrastructure that handles messaging, so it comes down here, and then infrastructure needs to go up and tell the application layer that, hey, I just got a message, you need to execute something, and then that isn't allowed, right? Because you're not allowed to go upwards in the stack. So the solution to that is you put infrastructure under presentation layer. This feels icky. I don't know why, it feels like one of those, hey, we found a limitation, if we just move this thing, everything is fine. So this is something that actually comes out of the book. I'm not making this up, this is a suggestion from Eric Evans. That means that your message comes in at the infrastructure layer, which can then call the application layer, it can call the domain layer, but now you're screwed again because the domain layer now needs to save something which goes up to the infrastructure layer, and then you're pooped again. And you can't do that because you can't go upwards. So the solution to that is you keep this layer architecture, you do infrastructure under presentation and then application and domain, and then you make sure that you inject your infrastructure information into the lower layers. You make sure that the lower layers depend on abstractions for the infrastructure, and then you're good to go because it makes it possible to receive a message on the infrastructure layer, going to application, going to domain. Domain calls a local interface, which happens to be implemented up here, but architecturally, it's not going up, right? Because I'm calling something down here. Sweet. Now, somewhere along the lines, somebody came and said, hey, I'm going to do it like this instead. And I think this is probably one of the more used models, even if a lot of people don't know that they are actually using it. It is called ports and adapters, or onion architecture, or it has a bunch of different names, but the original name is ports and adapters. And the idea here is that we don't think of it as layers going from top to bottom, we think of layers going inwards instead. So you have an application, and then you have inside the application, you have application services, and the application services talk to the domain model, and you only talk inwards. Then you create inputs in different ways. They are on the left side of a diagram like this. So you can have a browser or a REST client or a gRPC client or potentially a queue or an email or whatever, something going into the system. And then every one of those ports has an adapter. That adapter then takes whatever is coming in from each one of these different clients or these different ports and adapts it into a call to the application services layer. And then the application services layer talks to the domain model to basically get stuff done. And then the domain model talks to the application services through those injected interfaces and interface implementations to an adapter that then uses a port to talk to output things, which is on the right-hand side of your diagram. Nobody really cares about this diagram, but that is kind of what we end up building in most cases today, or I do at least. But important to know is that we have the same layering. It's still the same idea that you talk from one layer inwards, but you don't talk outwards. If you need to talk outwards, like from the domain model out to the output ports, it is done through an interface that gets injected inwards. So basically this, you define an interface in your domain model, you implement it in some of the outer layers, and you inject it into your domain model. That means that the domain model doesn't know about anything outside of itself, it only knows its own things, and then can call the other layers indirectly. And then you can also go and say, hey, I want to implement my services either in the application services layer or in the application layer like this. So in this case, my domain model uses an iEmail server. It only knows about iEmail server, but the actual implementation of iEmail server is Microsoft 365 email service, which then talks to Microsoft 365, which then kind of means that your application services are allowed to use that implementation. So your application service could, in theory, use the domain model's iEmail service, but I would recommend that you create your own interface in that layer so that each layer is a separate boundary that doesn't depend on other people's interfaces. And then the bigger part of the book talks about the domain and how we turn the domain into a domain-driven domain model that we can work with. Now, the problem is with the domain is that it's often very big. And you have that old saying, there's only one way to eat an elephant, a bite at a time. No, there is not somebody, nobody knows where the quote comes from. So if you come and tell me that Nelson Mandela said this, he stole it from somewhere else. I have checked this, unknown, important. But the reason I bring this up is that I work as a consultant, so I generally come into new domains all the time, and I assume that some of you are consultants as well. Anybody? Quite a few of you. How many of you have walked into a client and on day one said, sweet, I understand this domain, it's going to be a piece of cake to work with? No one. How many of you have walked into a client and then left the client that afternoon feeling a bit sweaty and a bit nauseous going, I will never understand this because this domain is bonkers? Most of us have. I just moved into a new client. I have a bank as a client right now. I'm not a financial IT guy at all. And the domain we're working in is a metadata-driven system on top of a metadata-driven system on top of a governance system for the entire bank. It is like that. And the only way to solve that is basically break it down into smaller parts and then take one part at a time and fix that, and then over time you get to understand the entire thing. And the way that DDD does that is that they divide the domain that you're working in two different ways. So first of all, it divides your domain into what is called core domains, subdomains, and generic subdomains. So the core domain is a part of the domain that you are working on that is the most important part for you. Then you might have other supporting domains. So basically we've taken the big domain, broken it into smaller pieces, and then you work on one piece, and that's your domain, but you are still dependent on other domains to get your work done, right? You cannot live in isolation, so you have these supporting subdomains that help you. They are important, but they're not important to you for you to build, right? And then you can depend on what's called generic subdomains, which is this is a piece of functionality or a domain that I need to be able to do my piece of code, but I'm not building it. Somebody else is building it, but it's also so generic that I can basically go and buy it off the shelf. So for example, I'm building an eShop. I am focused on my eShop functionality, but to be able to build my eShop, I am going to need a loyalty program, and I'm going to have some user management. Now, those things are important for my eShop to work, but they're not my main concern. I can build my eShop, as I said, and I can focus on that, but those things are things that other teams in my organization are going to build for me so that I can use them. And for them, the guys in the loyalty program, that's their core domain, and for them, the eShop becomes a subdomain that they support. And then for my eShop, I might need inventory management and newsletter management, but they are generic subdomains because honestly, inventory management is complicated, but I can go and buy that off the shelf on the internet. And newsletter management, I can go and buy that as a service on the internet as well. So they are generic subdomains that I need to have, but somebody else has already solved it, so I'm just going to pay for those. Now, inside of a subdomain, or a domain, sorry, you also have what is called bounded contexts. This is such a weird concept to get your head around when you read the book. It took me ages, because the hopeful idea of it is that there's one bounded context for each domain. But if the domain, like a web shop, is too big for one team to cover the entire domain, you might split your domain into smaller contexts and let one team work on each one of them. Then you get two bounded contexts inside of one domain. This is a pure practical thing about the fact that you cannot have a team of 60 developers working on the same thing because they're going to cause problems. So you split it up into bounded contexts, and then you basically say, hey, we know how these are going to talk to each other. So bounded context X, so team X is going to work on this part of the domain. Team Y is going to work on this part of the domain. And then they sit down and they agree on how to translate the different things between the different domains so they can work in isolation, but they have an agreement on how they do interaction with each other. This is kind of good if you have a domain that is too big, but you do want to try to avoid it because it makes it more complicated, right? And the reason for this sort of very strict way of looking at it is in the world of DDD, it also means that there is a ubiquitous language in this bounded context, and there's a ubiquitous language in that bounded context. Even though they're working in the same part of the domain with the same kind of things, they have a different ubiquitous language, because down here they might have defined that a user has first name and last name and email, whereas in this part of the domain, I maybe don't need the email, but I need an age instead. So a user are two different things here. In the ubiquitous language, they have two different definitions. But if we ignore the ubiquitous language part, It's just a matter of taking your domain, breaking it into subdomains, and then if you need to, break those into bounded context and let those teams work freely, but make sure that they can communicate. Bringing it into a 21st century kind of thing, if you see these as microservices, but they're still in the same code base, but basically a microservice is the same thing. They can build their thing and they can build their thing as long as they know how to talk together to solve the end goal, right? I do want to mention that defining subdomains and bounded context is really, really complicated, and Eric Evans is really open about this, and he pretty much says that you are going to fail. That's just the way it is. You will never succeed with this, at least not the first try you do, and probably not the second, third, and fifth time you do it in your code base. But over time, you get better at defining how you can split your entire domain into smaller things that can still work, and they are not too dependent on each other. But at least take a step back and look at your elephant and sort of go, is there a way to split this? Is there a way to split this into different parts that we can work on individually? Are there things, and this is a thing I think a lot of developers or teams miss out on, is there a way for us to split off a part and just go and buy that? Can we not just subscribe to some online service to do that part of the system so we don't have to build it? Oh, that costs money. Developers cost money as well. In the end, building it yourself is going to give you an inferior product at a higher price in most situations. But then when you split it, you have to start talking about communication, because these different systems are going to communicate, or these different domains. So they spend a lot of time talking about communication in the book. And here's an example. So in my domain, I defined order and order lines. But then in my supporting subdomain, they decided to build a generic model where you only have item types, and then items can reference other items of another item type. And then there can be an item type order and an item type order line. And that makes it very generic, and was really useful in this part of the domain, really sucks in my part of the domain. So developers tend to do, I'm just going to go and replicate their model into my model, and then whenever I talk to their model, their domain, I'm going to take what they send back, and then I'm going to have these little to item and from item things so I can move from their implementation to my implementation. That seems pretty okay, until they change their implementation, because every time they change their implementation, now this part of my application is wrong and needs to be updated as well. And then it gets even worse when you cannot just go and say, hey, can you give me this order? But because they have built it like this, it requires 4 different web calls to be able to get the thing I need so that I can build up one order with order lines. That would suck and would make it complicated to work with. And then, once again, developers tend to go and say, sweet, we can fix that. We put all of these calls into a service. Then we just call the service does multiple calls, and it returns an item, and then we use to item and from item, and we have isolated all the calls, which is a step in the right direction. And we can then also go and put in what red on black is bad. We can now go and put in what they call in domain-driven design intention revealing interfaces, which is basically we put an interface that reveals what you want to do. It's like, what do I provide? So we name things in a useful way so it makes sense to use the interface. But we're still stuck with this kind of annoying part where we have their domain model inside of our domain model as well, just to be able to do to item, and we have a very hard dependency on if they ever make any change, it affects us as well. And that is where, yeah, that was kind of what I wanted to show. What I just said. That's where anti-corruption layers comes in. So in DDD, they make it a point of making a separate thing to do the conversion. So they actually create this extra layer in between that knows about both of the representations and can do the mapping between them. But it means that in my domain, I call an intention revealing interface that basically says I want to get an order. And then I have this whole piece of code that knows how to get the wrong type, the item and item type, and do the conversion and everything for me, and then give it to my domain. That means that my domain is completely separated from this implementation. It only knows about order and order lines, and whenever this changes, we need to change the anti-corruption layer, but our code on that side stays the same, and there's only one data model in there. Does that make sense? kind of a nice way to do it, and basically making sure that you push all of that out so your domain is cleaner. And then they talk a lot about asynchronous communication, and developers tend to love strong consistency, and they want to have it everywhere. And then you go and talk to the people, the domain experts, and they go, oh, we have that batch job that runs every night. Yep, which means that strong consistency is not a requirement, because currently their system is eventual consistent, updating every night, which means that we can probably make our system eventually consistent as well, which makes it a lot easier to build systems because you can use things like queues to make it more secure. And that brings us into messages or events that they have in DDD. They talk a lot about that. And we've got these events that we generally talk about as developers. It's like we send messages between different domains, or if you want to call them, like we send messages between different microservices or different services in our architecture to update the information so that we know the data is synchronized between them and everything like that. We know these events and these messages, but they talk, or Eric Evan talks about domain events, which is a whole different story and really, really sweet. So a domain event is something like this. They are events that happen inside your domain. So basically account created or order completed or user account tier changed events. And then whenever something like this happens, when somebody creates an account, you raise this event, the account created event. And initially nobody cares maybe. Maybe you just raise that event and it goes into the ether and nobody cares, it's fine. But then in the future somebody might care and they can just plug into that and say, oh, whenever a user account is created, we're going to send a welcome email. Oh, whenever a user account is created, we need to do X. And whenever a user account is created and it was created between these two dates, they should get a little bonus on their account or whatever, and you can just plug in. So you basically just do this. Raise event, you raise the event, it goes into something, some form of mediator pattern, either over a service bus or just internally, most of the time probably just internally. And then when product owner goes and says, hey, maybe we could get people to keep their premium accounts if we offer them a discount on downgrade, and the developer just goes, we have this user account tier changed event. I can just plug into that. Don't need to modify any code, just add a piece of code that listens to that event, and whenever that event happens, we send an email and say, hey, would you like to stay if we do this? Can we send everybody a voucher if they buy a blender this week? That's a really annoying thing to check in the checkout. But then you go, there's this order completed event. Let's just create a little thing that listens to that event, look at the order, is there a blender in there? Yes, there is. Send the voucher. And then, yeah, once you get into messaging, you have to start talking about synchronous versus asynchronous communication, strong versus eventual consistency. DDD solves that with aggregate roots. There's only one type of objects or a few types of objects that you pull out of the database. You only have a repository for aggregate roots. And then if you need to get anything inside the aggregate root, you always go through the aggregate root. And then that is the thing that defines a consistent save. An aggregate root is always saved as a unit, and that is your consistency boundary. This is semi-complicated stuff, but it's worth reading up on with the aggregate roots in DDD. But mainly think about consistency and don't just go, it is so unlikely that something happens right here that we can just accept that possibility. It's like, no, make sure that you get consistency if you can, or just think about it and go, no, it's too much work to make this 100% consistent. We are willing to fix any form of inconsistencies after the fact because the cost of basically mitigating them is too high. And then the last thing is, what about consistency with messages and domain events? Because if you have this situation here, we save an entity or an aggregate root, and we save that to the database, and then inside of a transaction, obviously, to make sure that everything is saved together, and then we send the message to the message bus. Now, what happens if the message bus is not available? Because that's going to happen outside of the transaction, right? So now we have a transaction that has gone through, a save that's been done in the repository, but an event has not gone out in the service bus, and now we have an inconsistent state because the database is updated, but everybody in the other services don't know about it. Or even worse, what happens if the network goes down? Because now we don't know if the message failed to send because the network went down or because we couldn't reach the service bus. Because it could be that the message went to the service bus and then somebody cut the wire, or it could be that the wire was cut to begin with and we couldn't reach the service bus. We don't know. Should we roll back the transaction? Should we undo our... Don't know. It makes it complicated. Somebody then says, hey, let's put the send event inside of the same transaction. Okay, that's kind of cool. If your service bus supports distributed transactions like that. But what happens when the entity then fails? Most service buses will not have like a nice distributed transaction thing, so it will just be, it will be sent. And then if saving it fails, then you end up in an inconsistent state again. And this is actually very simple to fix. You use what is called the outbox pattern. You basically take your event, you save your entity and your event to the database in the same transaction, so you know that they are always saved in one place and they're consistent. And then you create another little tool that goes and looks for the events in the database and push them to the service bus. This means that these events will always go to the service bus, with the little caveat that, hey, doesn't that mean that you still have the problem in the publisher, and if the publisher can't send the event, then it will retry and you might send the message more than once. Yes, that is the way it works, and that is the way that messaging works. You will always, most cases, just have a at least once delivery for messages, so you need to take that into account that the message might be sent more than once. That's just the way it works. I also want to quickly, I'm on the last minute. CQRS, I just want to mention, fits very well into domain-driven design, where you separate the queries and the reads, or commands and queries, sorry. But then the question always comes up, if you do CQRS, do you need duplicate databases? Do you have one database that you actually run your transactions against, and then you have another read replica that you only do your reads against? You can do that, or you can just skip it. It works fine to do custom reads in the same data store. You can make simpler reads in the data store with something like Dapper, for example, to just get quick read models. And then you use Entity Framework with a lot more information in it for your queries or your commands. So it's fine to run the same database. Yes, there are downsides, but it makes life a lot easier. So CQRS with one data store is a nice thing to put into your DDDs as well. Having two models, will that violate dry principle? You can take that dry principle and, yep. Let's just leave it at that. We overdo dry in lots of cases to the point as developers it has to be dry, so we have this common class library, and then all of a sudden 95% of your code is in that common library because they reuse 4 lines of code somewhere. Dry is nice, but we can also just go and say, in some cases, it's better for us to replicate code that is not complicated or very important, and replicate that in multiple places instead of basically shoehorning together two things that don't really fit together. So dry is not my favorite principle. And the goal, Eric Evans sums it up nicely with the goal is that not only can a developer understand what the code does, he or she can also understand why it does what it does and can relate the ongoing communication with the domain experts. That's kind of what we want, and that's what you can do with these patterns, hopefully. I want to thank you all for listening. I'm 2 minutes over. I'm really sorry about that, but you're going to be stuck here anyway because you're not going to be able to find your way out. Feel free to leave an eval if you liked the session. If you didn't like the session, I am available. Come up here and tell me why you didn't like it. I will explain why it was great, and then you do a great eval so I can come back. Thank you all so much.